Good afternoon. Thanks for joining us across the fence. I'm Fran Stoddard. Vermont's first Tech Challenge Championship will take place this Saturday at Champlain Valley Union High School in Heinsberg. The first Tech Challenge involves teams of high school students and their robots. The students are responsible for designing, building, and programming their robots to compete against other teams. As the teams were getting ready for last year's championship, they were also dealing with the height of the pandemic. We met one group of students who overcame the adversity through teamwork and technology.
The robot Isaac Vernon is building may not look like much, but he's confident in its abilities.
Yeah, I tested it out yesterday. That's how I know it shoots 20 feet. This is the third iteration of the shooter, actually.
Vernon is a member of the 4-H Manchester Machine Makers. They're competing in the first Tech Challenge. It's a robotics competition for students in grades 7 to 12. Teams design, build, and program robots to compete in head-to-head challenges. Vernon and his teammates have learned to adapt and overcome to any and all challenges.
What I learned this season was that not being able to meet in person is a lot more challenging than working on a robot while you're all together. The last time we met in person was all the way back in early November. We've figured out a whole bunch of tools to help with this, because we've been using Chrome Remote Desktop to figure out how to program the robot remotely when it's over in like a town 30 minutes away. We have a controller hooked up to a computer, then that computer is a client that runs to the host with the robot, and the robot has like a phone connected to that, which goes to the robot's phone. So it's like this huge setup that allows you to operate it remotely from anywhere in Vermont.
It's gotten us more efficient, I want to say, because it's gotten people knowing what they're going to need and planning ahead.
This is Charlotte Ruley's second year competing in the first Tech Challenge.
What do you like about robotics?
I like the precision, the being able to do math and know if something's going to be good or not. And so for the grabber I'm building, we had to do the torque calculations for the servos to figure out if it was going to be able to lift the wobble goal. It was just very precise and like nice and neat and like yes or no, this will work. And there weren't any like hypotheticals. It was just lovely.
The First Tech Challenges are a part of FIRST, the world's leading youth-serving nonprofit advancing STEM education. STEM is short for science, technology, engineering, and mathematics.
Oh, I really love robots.
John Cohen is a UVM Distinguished Visiting Scholar with the College of Engineering and Mathematical Sciences.
Part of my assignment at University of Vermont, I was working with colleagues like Doug Dickey, the Assistant Dean for the College of Engineering and Mathematical Sciences, and people at the Generator Makerspace, where I'm a founding board member. We came together and applied for a grant called a First STEM Equity Grant. And the idea is to try to get the STEM programs at all different levels to be able to better serve underrepresented groups, you know, women, BIPOC, LGBT, and luckily for us, also rural people who are just underserved.
Thanks to Cohen and his colleagues, Vermont was selected as one of 12 recipients worldwide to receive a grant. The award of $40,000 will go to everything from kits to build the robots to establishing hubs where students can gain access to this technology. For Cohen, this is an opportunity to boost awareness and access of STEM programs in order to showcase the talent of Vermont students.
Whoa, did you see that?
I think my big takeaway is the sort of resilience and creativity of people. You know, when I think about Vermont, you know, you think about our brand of our brave little state. It's this kind of, you know, Yankee ingenuity, and man, is it on display here.
Ruley and Vernon agree.
You're given a problem and you get to work around it rather than through it. And it's just creative ways of solving the same problem. So it's, yeah, I don't know. You get to do the math behind it. It's logical, but it's also creative, and it's fun.
I like that it provides a lot more opportunities and like real world applications. It's almost like making a startup business because you have to market your program to get more people to join, engineer, design, prototype, and you have to meet the deadline of the competition. And it's interesting to go through the engineering process over and over again to design something that you get to use in a competition.
The First Tech Challenge teaches students to compete in a world of uncertainties. It's good experience to have when you're living through a pandemic and getting together with friends virtually to build a robot. In Essex Junction, I'm Keith Silva with Across the Fence.
Again, this year's Challenge Championship will take place at CBU on Saturday. At colleges and universities around the country, Fab Labs are springing up. Fab Labs are short for Fabrication Laboratories. The University of Vermont is one of the leaders in Fab Labs. UVM opened its lab 10 years ago, and over the years, it has served as an incubator for ideas. Rebecca Gollin checked the UVM Fab Lab a few years ago for a special course involving first-year students.
A new class at the University of Vermont is giving first-year students a decidedly different kind of experience.
We had to build this thing called a bioreactor for a rat lung because they're working on this thing where they're trying to resell different organs with so say I needed a lung transplant, they'd be able to take someone else's cells out of it and put mine into it.
The students are working in groups to come up with solutions for a problem they were presented with in the beginning of the class.
We've been assigned to provide an environment for plankton that they can eat algae.
It's a biology class, but with a twist.
We saw a real place for this sort of maker movement in biology, not to necessarily do biological experiments, but to build equipment to do experiments.
It's called Bio-Fab Lab, and it's offered to first-year, first-semester students who want to explore a biology or life science major. Much of their work is done here at the Generator, a makerspace in Burlington where the students learn how to use 3D printers, laser cutters, and other specialized machines to create their designs. Andy Mead teaches the class.
The idea of the class is to expose those students to a side of doing science that they wouldn't get exposed to until much later in the process. It's sort of a kind of creative side of doing science. No, it's got to be the same because these all have to be total length of exactly the same, right?
Mead says that often when a researcher wants to do an experiment, they must first construct a dedicated piece of equipment to be able to continue. The projects being created here are more than just an exercise. These devices are needed by labs right here at UVM.
Right now, I've actually got an experiment going on where I'm looking at the impact of elevated temperature on the different life history stages of copepods.
Lauren Ashlock is getting her PhD in biology. Her focus is evolutionary biology, specifically the tiny crustaceans called copepods that are stored in these bins. Ashlock realized that a new piece of equipment could help with her experiments.
I was reading a lot of papers on doing feeding experiments with copepods, and a tool came up again and again called a plankton wheel, and I didn't know what a plankton wheel was, so I Googled it, and it came up with an image of a Hot Wheels car with plankton from SpongeBob on it, and that wasn't quite it, so I had to do some more digging, but essentially it rotates your samples to keep everything in solution, kind of to mimic ocean flow in a lab environment.
Ashlock knew that building this kind of machine would be a big undertaking, so when the opportunity to work with the Bio-Fab Lab class came up, she jumped on it.
Time and resources are huge. It costs money for the materials, but also for the expertise in, laser cutting and 3D printing and all of these things that I'm certainly not an expert in. And having the students really take that on and, claim ownership over that project, I could see it got them very excited, but it also for me definitely reduced, the labor and, mental input that I had to put into doing something like that. So I was able to continue with the research I'm doing now, knowing that they're making this awesome tool for me to do an experiment in the future.
Building a piece of working machinery is a daunting task, especially for students who are still undecided about their future in science.
At first I even left the class because it seemed like so much work, but then I ended up coming back the same day I went to the advising center and got switched back into it because I was actually kind of excited to see where the project that we were building would possibly go.
The early part of the semester is spent learning how to brainstorm and coming up with as many ideas as possible.
One of the keys of brainstorming is that you don't eliminate any ideas at first, during the first pass. You write down everything you can possibly think of, as silly as it might be. Because even silly ideas might have some good idea hiding behind them.
Even things that might just seem like a pipe dream at first could actually be useful later on. So honestly, that it's not just for this. That's definitely a useful skill that can be used throughout in pretty much any subject where you have to use critical thinking skills, where you have to really think on your own without the help from others.
The class is funded by a 2-year grant from the National Science Foundation, or NSF. That group is interested in whether this hands-on approach will attract more students to science-based fields.
There are two aims of the grant. One is to identify aspects of the maker movement that work really well for students to learn basic concepts, and the other is to understand, to ask whether or not this approach increases attraction to and retention in life sciences.
For UVM, one goal is to use information gathered from the students to better serve those who are thinking about a future in science.
It's really kind of changed my experience, how I think about designing things in college so far.
It's definitely made me rethink about my major. I love physics and I think it's a really cool path, but the reason I value mechanical engineering more is because it's so much broader, and I could be doing something with biology, or I could be doing something in the medical field, I could be doing something with space, and that's kind of what I like about it.
It's a new opportunity for UVM students to get creative close to home. In Burlington, I'm Rebecca Gullen with Across the Fence.
And that's our program for today. Thanks for joining us Across the Fence. I'm Fran Stoddard. Stay well.